A boy ties a stone of mass 100 gram to the end of 2-meter long string, whirls in around the horizontal plane. The string can withstand with a maximum tension. This is the maximum tension. So the maximum speed, so with which the stone can revolve, is revolutions. This is what we need to take care on. This is what is mentioned as it's a revolution per minute. Okay, revolution per minute. Whose value is this? Revolution per minute. Okay, RPM is the whose value is this? This is belonging for what? It's a frequency. This is frequency. Yes, RPM, revolution per minute. Revolution means what? One revolution by 60 seconds. So this is what? 1 by 60 RPS. 1 RPM is equals to 1 by 60 RPS. Just to keep in the mind. Okay. So we are moving to this now. A boy ties a stone of mass. This is the mass as mentioned. Just to go on this clarity. And its length is what? It's a 2 meter and whirls around. So it whirls around the horizontal plane. Yes. Maximum tension is given. This is what it's a T. Okay. It moves in circular path. Yes. So this is what? It's a string. Here is the block of mass. Some body, its mass is given like M. Yes. So next one, we are moving on this situation. It's what when the particle is moving in circular path, which force comes into play? Central forces comes into play. Central force is balanced by what? Tensional force. It's a tensional force is T. This is what? mr omega square, otherwise mv square by r. Okay. So its direction of motion is towards here. So is the direction of motion with radius, fixed radius. So this is what? In a horizontal plane. It's not in vertical plane. Okay. So now we are moving on this. So this is T is balanced by what? T is equals to mr omega square. Now what's the omega? Omega is what? 2 pi f. Omega is angular velocity. R is the radius. The radius is what? Which we have taken as a length L. Yes. M is the mass of this particle, is a given situation. Yes. So then T is given. What is the T? It's a 80 is equals to, so the mass is what? 100 gram. So 100 into 10 to the power of minus 3. R, it's a length. Length is what? 2 into omega 2 pi f whole square. So if you do the calculation, we are getting about this. This is what? The value of frequency. Okay. Let us check on this. So for this is 0, 1 0 cancels, 8 2 1s to 4s. It's a 4 is equals to 10 to the power of minus 2, right, into 4 pi square f square. Okay, do it carefully. Yes, so this become as 4 by 10 power minus 2. Yes, 4 by 10 to the power of minus 2 is equals to 4 pi square f square. Correct? 4 and 4 cancel. 10 power minus 2 will become as 10 power plus 2. So then become as, what do you say? 10 square by pi square is equals to f square. Then f is equals to what? 10 by pi is the case. So what are the units of this frequency? So this is what? It's a revolution per second. Okay, it's a revolution per second. My f is equals to 10 by pi. Revolution means what? RPS. 1 RPS is equals to 60 RPM. So this I can take about this. It's a 60 RPM. Then what do you say? It's a 600 by pi. 600 by pi RPM is the case. So is talking about this K by pi revolution per minute RPM. So the value of K is what? This K is equals to 600. Option C is correct. A particle experiences a variable force as given. This is variable force in terms of x and y. In a xy plane, okay, so assume a distance in meters and force in Newton in SI system, okay. If the particle moves from the positions, these are the things, that's what 1 to 2, 2 to 3 in the xy plane, the kinetic energy changes. So by looking this one, we are getting very clearly on this. This is based on what? Work energy theorem, okay. So what the concept is linked with this? The concept is work energy, okay. So work energy theorem, yes. So work energy theorem. But what is the work energy theorem? So work done, W is equals to the total work done, okay, work done by the all the forces on a system is equals to change in its kinetic energy. Yes, but what is asking? Is asking about this kinetic energy changes. Kinetic energy changes means what? What is this? Okay, I need to find this. To find this one, what to do? We should go for about work done. Yes, how do you go for the work done? So this is what work done by variable forces. Okay, so work done by variable forces. Okay, so work done by variable forces. So what is the condition now? W is equals to integration over fx dx plus integration over fy dy plus integration over fz dz. We know in the concept, yes, its limits are from where? X1 to x2, it's a y1 to y2, it's a z1 to z2. So is there z in the picture? No. Okay, there is no z. So then what should I go for? This term is what? 0. So now this w is equals to integration over. Now what is fx? This is fx. What is fy? This is fy. W is equals to integration over, so from x1 to x2, fx is given 4x dx. Limits from where? 1 to 2. Yes, this is 1 to 2 plus integration over fy 3y square dy. Limits from where? This is 2 to 3. Yes, 2 to 3. Go for proper integration, you will get the answer. Yes, so let us see now. First one, W as it is. Next one, 4 outside. Integration over x dx, x square by 2. Limits are from where? 1 to 2 plus. So this is 3. So it's what? Y cube by 3. Limits from where? 2 to 3. Yes, this W is equals to 2 ones to 2s are 2 times of, so 2 square minus 1 square plus 3 cancel. Yes, 3 cube minus 2 cube. Yes, this is what W. 2 times of 2 square is 4. 4 minus 1 is, it's a 3. Yes, plus 3 cube. So 3 is 9, 9 3s are 27 minus, it's a 8. Yes, so this is 2 3s are 6 plus 27 minus 8. It's a 19. 19. So this will become as what? 25 joule. So what is this work done? 25 joule. Work done 25 joule means what? What is the kinetic energy? So the kinetic energy is delta Ke is equals to 25 joule. So this is given condition. So the answer is what? Option C is correct. Here is the question. The question is what? Just a spring platform as mentioned. On the springs platform, here is a ball. Ball is dropped from certain height. Okay. When ball is dropped from the height, yes, whenever ball is dropped from the height, this can be compressed to the like this. This will be, it's a h by 2 is mentioned. Yes, compressed. Then this is what, yeah, first one I'm talking on this situation. So the spring compressed, yes, compressed to like this, okay, is the case. The ball came to here. What is the initial case? This is what initial. So this is what, it's a final one. Yes, two reference. So this is what springs constant is what, it's a K. Yes. So now we need to use about law of conservation of mechanical energy. Okay, sometimes I'm using that law of conservation of energy, the statement. So law of conservation of energy means what? All the energies. So I'm considering about this only. What is this? It's a mechanical energy. Okay, so the law of conservation of mechanical energy. Yes. Now for this is what anyone you can talk about this. It's a initial frame. This is what? Final frame. Okay, so total energy final, total energy initial. Correct? So total energy final. So what is the total energy final? Means what? At this position. It came from here. What is the initial velocity? U is equals to 0. Yes. So this is equals to, I can write you this, kinetic energy final plus potential energy final. So this means what? Kinetic energy initial plus potential energy initial. Now I'm substituting on this. Okay, so it's what? Kinetic energy final plus potential energy final is equals to kinetic energy initial plus potential energy initial, right? So what is the kinetic energy final? Half mu square. It's what? 0 plus potential energy m g. H is what? H plus h by 2 is equals to, when it came and it remained in equilibrium position, so what is the kinetic energy? 0. So then what is the potential energy? So potential energy is what? Potential energy we can say on these two cases. One is what? Potential energy due to gravity, potential energy due to what? Spring. Yes. So potential energy due to gravity plus potential energy due to what? It's a spring. So gravity, so this is what I'm taking as, this is the initial frame. Initial frame means what? Ground frame. Ground frame means what? Its potential energy what? 0. Okay, this one also 0. So now this is potential energy of the spring is what? Half k x square. Now we can substitute as this. So it's a mg times of 2h plus h. What is this? It's a 3h by 2 is equals to half k. What the compression? X stands for elongation or compression. Okay, x is what? It's a h by 2 whole square. Okay, you can go for this. Now a proper simplification we can get it on. This is the condition. Okay, so now I'm taking as this 2 and 2 cancel. Yes, so it's what? M, what is the mass? M g into 3h is equals to k into h by 2 whole square. Okay, so mass m is what? 10 power minus 1, g is 10 into 3, h is what? 10 to the power of minus 1, k into h by 2. So what do you mean by h by 2? H is what? H mentioned 10, correct? 10 by 2 centimeter. Means what? 2 ones to 5. So 5 into 10 power minus 2. Okay. 5 into 10 power minus 2. 5 into 10 power minus 2. Again 5 into 10 power minus 2. Yes. So now you can write it as 10 to the power of minus 2 means 10 power minus 1, 10 power minus 1, 10 power minus 2 cancels. Yes. Next one, 5 ones, 5 twos are, 2 threes are 6 is equals to, it's a k. Next, what left? 5 into 10 to the power of minus 2. So k is equals to 6 by 5. This become as 100. 5 ones, 5 twos are 0. Okay. So then k is equals to 6 twos are 12, 120. The value of k is what? 120 Newton. K value Newton per meter is 120 Newton per meter. It's not Newton into meter. It's a K unit is what? Newton per meter. A stone of mass m tied to a string is being wheeled in a vertical circle. So it's what? Based on vertical circle with a uniform speed. The tension in the string is talking about this tension in the string during vertical circular motion. This is what vertical circular motion. It's what center. Yes. So if you take about, this is the position. Yes, you know this. So it's what lowest position A, highest position B, horizontal position is what it says C. Like you, three cases we need to remember. So for any type of problem is asking based on vertical circular motion. Okay. So when the particle is moving in circular path, yes, if the particle is moving in circular path, now in vertical circular path, so the at the lowest condition, if you see, this is what it's a v1, okay, it's what v2, and next one is what this is v3. Yes, so for your kind information, v1 is what to complete one circular motion under root of 5gl. L is what its length, which is radius. So V3 is equals to what under root of GL. So to find out V2 what to do, we need to use the law of conservation of mechanical energy. Otherwise, some of can do that equation of motion V square minus U square is equals to 2AS. Okay. So now my question is about what is the tension? Okay. The tension at the lowest point is what? What is the tension at the lowest point? Yes. If any particle is moving a circular path, okay, which force comes into play? Central forces comes into play. Yes. So now we are talking about here its weight is what? This is mg, and tensional force, tension is what? T upwards, and next one is what? mv square by r. Yes. Tension at the lowest point, tension at the lowest point is equals to mv square by r plus mg. Yes, tension at the highest point, it's what? mv square by r. Yes, next one, its weight is what? mg, and next one, tension is what? Tension at the highest point is downwards. So then I can say this is what? mv square by r is equals to mg plus tension at the highest point. So tension at the highest point, TH is equals to what do you say? mv square by r minus mg. This is mv1 square, mv3 square. This is 3. Here I took it as a 3. Okay. So here tension at the lowest point, and next one tension at the highest point. Next one tension at the horizontal point. Here is what? T2. Its weight is what? mg. Central force is what? mv square by r. Yes, mv2 square by r. So then in the direction of its tension, so what forces are acting? Only central force. Then what? T at a horizontal point is equals to T at a horizontal is equals to then what? mv2 square by r. Yes, now the question is about. So the same through the motion, tension is same throughout the motion, it changes. Minimum at the highest point of the circular path. At the highest point is what? This is what is the condition. So mv square by r minus mg. Yes. So if you do the cross check also, so then what? Here what is this under root of 5gl, correct? Under root of 5gl. Yes. So this is square root of 5gl. First I am talking on this here. M V1 is what? Square root of 5gl whole square by r. Okay, gr I am writing like plus mg. So will become as what? M into square root cancel 5gr by what? R plus mg. R cancel 5mg plus mg. What is it say? 6mg is the at lowest point. Now you talk on this. M into at this position at the highest point. At the highest point is what? Under root of gl. So this is what? Square root of g into l means what? R whole square by r minus mg. So then m into, so this is what? Gr by r minus mg. So r cancel, mg minus mg. So this is equals to what? 0. Tension at the highest point. Yes. So from this, what you got to understand? So we can calculate the velocity at the highest point when we consider tension at the highest point is what? 0. Okay. Minimum. So minimum at the highest point is the correct option. Potential energy as a function is given by, this is potential energy is mentioned, U is equals to A by R to the power of 10 minus B by R power 5, where R is the interatomic distance, A and B are constants. The equilibrium distance between the two atoms is, this is completely based on what? It's a differentiation. Okay, you should know a proper differentiation and integration while solving the problems. Yes. So first one I'm talking about, just when we speak about this equilibrium condition, it's what? Equilibrium condition. Yes. So equilibrium, neutral one. Yes. So for the equilibrium condition, F net is equals to what? 0. F net means what? F is equals to what? You say minus du by dx or dr is equals to what? So this F is equals to minus du by dr. This F is equals to what? 0. So first I am talking about F. F is equals to minus d by dr times of A by r to the power of 10 minus B by r to the power of 5. Okay. F is equals to minus d by dr times of A into r power minus 10. So minus d by dr times of B into r power minus 5. So this is what? Yeah, minus of, right? So this is equals to 0. For the equilibrium condition, net force is equals to what? It's a 0. So this, now I'm writing on this minus, it's okay, gone. Then what is this? A into, what is this? Minus 10 into r power minus 11 minus of minus 5 into r to the power of, so r to the power of minus 6 into what? It's a B. So this you bring here, then what happened? Here minus now. Okay. So now go for the proper, so calculation. So this is minus 10a minus 10a r power minus 11. Okay, is equals to minus 5 into b r to the power of minus 6. Yes. So minus minus cancels. 5 ones are 5, 2s are. Yes. R power minus 6 and this become as minus 5. So 2a r to the power of minus 5 is equals to b. Yes. So r to the power of minus 5 is equals to b. R power minus 5 is equals to b by 2a. R to the power of 5 is equals to 2a by b. R is equals to 2a by b to the power of 1 by 5 is the answer. So the option is what? 2a by b whole to the power of 1 by 5. Option C is correct. 0.5 kg block moving at a speed of 12 meter per second compresses a spring a distance of 30 centimeter, means this value is what? X, either spring's compression or uh, elongation. So value is taken as X. The speed is hauled, then the spring constant of the spring will be what? Is the horizontal surface. Yes. So this is, let it be here, the spring is fixed here like this. Okay, this is the spring. Now a block is here, this is the block, its mass is what? M. M is equals to 0.5 kg, moving at a speed of what? 12 meter per second. Okay, compresses the spring. Okay, when it comes to here, then what it will be? And the next case I'm talking on this is the horizontal surface. The spring is compressed to here. Yes. So this block came here and compressed here. This is initial one and this is the compressed part. Yes. So how much is the compression is taken? X is equals to 30 centimeter. Yes. So here is the initial case is what? This is the block. Its mass 0.5 kg. Its velocity is what? 12 meter per second. And at this position, the velocity is hauled. So V2 is equals to what? V by 2. It's a V by 2. So then the Spring's constant of the spring will be what? What is the Spring's constant? K is equals to what? Yes. So we need to use the law of conservation of mechanical energy. Well, whenever the spring is there, when you talk about the potential energy due to gravity, potential energy due to spring, both to be considered. Yes. So now the first case I'm talking on this here, total energy. So at this position is what? Total mechanical energy initial, total mechanical energy final. Yes, total mechanical energy initial is equals to total mechanical energy final. Total mechanical energy is what? Kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. Yes. So kinetic energy is what? Half mv square. Correct na? Half m. What is the mass? 0.5. V square means what? 12 square is equal plus potential energy. Potential energy means what? There is the, it is on the ground, and potential energy means what? On the ground means what? Due to gravity is same for the all the cases. So that is what I'm taking as 0. Next one, kinetic energy is what? Half m. M is what? 0.5. V become as a V by 2. V by 2 means what? 6 square plus no potential energy due to gravity. Kinetic potential energy due to spring is what? Half k x square. What is the x here? 30 into 10 power minus 2 square is the case. Yes. Now we can find the value of k. Yes. Just you can go for the calculation. So this 2 cancels. Okay. So 0.5 into 12 into 12 is equals to 0.5 into 6 into 6 plus k into 30 into 10 power minus 2 means what? 0.3. 0.3 into 0.3 is the case. Yes. So now 12 and this is 0.5. You bring this side. Yes. 0.5 into 144 minus 0.5 into 36 is equals to k into 0.09. Yes. So now any manner you can do this one, simple calculation. So 0.5 is common. 144 minus 36 is equals to k into 0.09. Yes. 144 minus 36. 0.5 into 108 k into 9 into 10 power minus 2. Okay. So 9 ones are 9 ones are 9, 2s are, okay, and 12 5s are 60. 60 means 6, okay, is equals to k into 10 power minus 2. It comes down, then will become as what? It's a k is equals to 600. The value of k is what? It's a 600 Newton per meter. So here is the question. The question is based on force versus distance, means what? Area under Fs graph is what? Work done. Area of 4 graphs in descending order of total work done. Descending order, higher to lower. Okay? Higher to lower. Yes. So where W1, W2, W3 and W4 so are the work done corresponding to the given figures A, B, C, D. Yes. So descending order, which is greater. One thing remember, what are the key points we need to write from this? So area under Fs or Fx graph, area under Fx graph is equals to work done. It's a work done. Is the first case. Second one is about area under. So this is what? Positive work done means what? Positive and negative work. Area above the x-axis, is taken as what? Is positive work done. Yes, this is positive work done. Yes. Next one, same as below the x-axis, is taken as what? Negative work done. Negative work done. is the case. So now negative part, if you see, negative part area is, this is more negative, means what, it is least. Yes. So work done by this one is what, it's a least one, W4. Okay. W4 is what, least priority, means what, least work done, because it's a negative one below the x-axis. So next one after that, and work done greatest is what, from these cases areas, area of rectangle plus area of triangle, area of rectangle plus area of triangle, area of triangle, this is what, maximum. W3 becomes what, it's a maximum, this becomes what, it's a minimum. Yes, it's what, minimum. So and W3, W4. Yes, so you can choose from this one, option A is correct. A stone tied to a string of length L is filled in a vertical circle. So the concept is what, based on vertical circular motion. Careful on this. When you speak about this vertical circular motion, we should aware about this, how to use the law of conservation of mechanical energy. Okay. So with the one end of the string, and at a certain instant of time, the stone is at its lowest position, has a speed is what, v. The magnitude of change in velocity, careful on this, magnitude of v bar minus u bar we need to find. Magnitude under root of v1 square plus v2 square minus 2v1 v2 cos theta. Okay, as it reaches the position where the string is horizontal. Yes, let me come to the point. This is what, vertical circular motion. Yes, now here is the point. This is the body. Yes, at the highest point here is the case, right? So now, sorry, this is the horizontal point. Now I'm using on this very first case here, the situation. The velocity at this position is what, u. So let it be, the velocity at this position is what, v. Yes, its length is what, L. So definitely this also what, it's a L. So what to do? We can use law of conservation of mechanical energy. How to use the law of conservation of mechanical energy? Before using that, we need to choose that where are your reference lines. Okay, so first one, now I'm taking on this, the reference lines are I'm choosing as like, this is what, horizontal. Okay, for first one, ground frame. Next one is about like this, correct? Yes, so you can use it now. First one is, this is the initial, this one is final. Total energy initial, total energy final. Yes, same like we have been doing for many problems based on this conservation of mechanical energy. Total energy final is what, kinetic energy final plus potential energy final. Is there spring? No, there is no potential energy due to spring, right? Next one is what, kinetic energy initial plus potential energy initial. Now we can apply this. Kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. Yes, kinetic energy initial, where is that? This is the initial point. What is the kinetic energy? Half mu square. Potential energy, this is your ground level, right? Okay, so ground, 0 potential energy level, correct? So it's what, 0 potential energy level. Okay, so means potential energy is what, 0 due to gravity, is equals to, at this point, half m v square plus potential energy mg h is what, it's L. So now we can talk on this, m common cancel, correct? Half u square is equals to v square by 2 plus g into L. Yes, what do you need to write from here? V. Okay, v square by 2 is equals to u square by 2 minus gl. V square is equals to u square minus 2gl. V is equals to under root of u square minus 2gl is the final velocity. My question is now, he's asking about this magnitude of change in velocity. Okay, what is the magnitude of change in velocity? Yes, you can use this. So this I'm talking on this magnitude of change in v bar minus u bar is equals to under root of v square plus u square minus 2vu cos 90. Cos 90 value 0. So this is what under root of, what is the v square? This. What is there? U square minus 2gl plus u square only is equals to under root of 2u square minus 2gl. So this is equals to under root of 2 common u square minus gl. Okay. So u square minus gl. So what is the value of x? X is equals to what? It's a 2. So the answer is what? X is given what? 2 is the answer.